Okay, Bismillah. Right, folks, I'm going to be doing questions 1 to 6 again because we had some technical difficulties with the sound. When I looked at the video, the sound had gone. So this is take 2 on questions 1 to 6, inshallah. Bismillah. Right, without any further delay, let's get this moving. So we're looking at the pixel paper, live mock Paper2 calculator. Okay, let's move it down. Let's calculate aloud. Here comes the first question. You must write down all stages in your working out. Right, here we go. Now let's choose ourselves a pencil. Actually, we have here A to B. Okay, let's have a look. A to B is parallel to C to D. So when we have parallel lines, we have certain arrangements. Like for example, we have F angles here, or we call them, the proper word for that is corresponding angles. We also get Z angles, which the proper word for that mathematically is alternate angles. Now it goes here, write down the value of Y. So I'm going to choose my highlighting tool now, and I'm going to highlight for you this part of the parallel line and this part of the parallel line, and what joins them up together here. I'll just choose a different color. Okay, now as we can see a Z shape here, the correct word for the Z shape is called alternate angles. So we know that 58 and Y are equal. So we can give an answer, write down the value of Y. So Y is equal to 58 degrees. And the reason why is because we're going to say, as I said before, even though we learn in school Z angles are equal, that is not a mathematical term. That's what we use to understand the question. But the correct terminology, mathematical terminology, is alternate angles. So we say alternate angles are equal. And if you want to do, I can't really say anything more than that. That should do the job. Question. Use your calculator to work out the value of 45.6 times by 123 divided by, that line stands for divide, divided by 0.34 squared minus 0.28 squared. Write down all the figures on your calculator display. So let's first of all grab our calculator. Our calculator's over here. Just bring it in. Okay, now we need to use the fraction button over here. Okay, I think we need to change back to a mouse. So, use the fraction button. We have 45.6. 45.6 multiplied by 1, 2, 3. You have to press the replay button, it goes to the bottom. 0.34 squared. And minus 0.28 squared. 0.28 squared. Press equal, and that gives us this number here. So let's get our pen back in. Okay, so we have write down all calculators. So 150,774.1935 is all of the calculators displayed. Now the next part of the question, they want us to, if we move the calculator out of the way so you can see it. The next question says, write down your answer to part A correct to 3 significant figures. So let's have a look. So we have our first, second, third significant figure, because they start from the first number of significance, first non-zero digits here. So now we need to put a little. Okay, so we call this digit here the last digit. So the 0 is called the last digit. The 7 is called the decider digit. If the decider digit is 5 or more, we add 1. Okay, so we have 0, add 1, so we're going to add them. is 1. 5 and nothing is 5, and 1 and nothing is 1. And then here, from this part, from here to there, we must fill in with zeros up to the decimal point, and these numbers get thrown away. So you have 1 0 here, 1 0 here, and 1 0 here. So the correct answer for that is 151,000 to 3 significant figures. Okay, thank you very much for joining us on this question. Okay, Bismillah. All right, question 3a, nice algebra question. Nice and simple. Simplify m, add m, add m, add m. Just quickly grab a pencil. So we have, you can think of this as 1m, 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 1m. So 1m add 1m add 1m add 1m will give us 4m. A common answer here, which is a mistake, is m to the power of 4. We will get m to the power of 4 if you were multiplying, but we're adding here. So that is the correct answer. Adding up like terms. If you think of it as like adding monkeys. 1 monkey add 1 monkey add 1 monkey, 1 monkey is equal to 4 monkeys. Simplify p times by q times by 4. If you couldn't get a simpler answer, this is nice. So we just simply take the times sign there, put the 4 in the front to make it look nice, and the answer becomes 4pq. Next one, expand. Now expand, okay, we multiply, another word for multiply the brackets. So I'm trying to illustrate it here. So we have 5 times by 3x. Okay. Is the first part. And then we have 5 times by minus 2. 5 multiplied by minus 2. Well, 5 times by 3x will give you 15x. And 5 times by minus 2 will give you minus 10. And that's the answer to this one. Okay, I'm sure that is the end of that particular question. And that's it. Lovely. Okay, Bismillah. Question number 4. We have here. Okay. Naomi wants to find out how often adults go to the cinema. She uses this question on a questionnaire. How many times do you go to the cinema? Not very often, sometimes a lot. Write down 2 things wrong with this question. So let's choose as well. Okay. Now the first thing I heard, how many times do you go to the cinema, is the bit that's missing. How many times do you go to the cinema every month? So we have no time frame. So we have no time frame in the question. So we're not talking about is it per week, per month, per year. And that will do as an answer for that part. The second reason, if you look at the answers, we have it not really often, sometimes a lot. These words mean different things to different people. So we can say that the answers provided, or the responses are vague. They mean different things to different people, so you get different results from the same question. That will do for a full answer for question 4 part A. Now if you want to look at part B, if I get hold of the paper in my hand. Okay, part B is talking about how do we improve the question. Design a better question for a questionnaire to find out how often adults go to the cinema. Okay, I'll just quickly move it down for you to show you what the question is, and we'll do it in the same place over here. Okay, that is the new question. Design a better question. Okay, for her questionnaire to find out how often adults go. So we have to redo the question. So I'm going to move it back up so we can compare, and we'll do it in the same space that we had above there. So we can look at the original one and look at our new one. Okay, so I'm going to do my part B over here on this side over here. Alright, let's have a look. Okay, so we're going to write the same question but with the time frame now. So we are going to say now, how many times do you go to the cinema? Per month. So, no time frame here, yes time frame here. So that was a poor question, a much better question. Now let's look at these response boxes given 1, 2 and 3. We can have about 4 response boxes being more than sufficient. And let's think of something a bit more better. So for the response boxes, let's just change color first. Let's go for a green. So we could have somebody who doesn't go at all. So we can have a 0 response. You could say you can go from once to twice a month. You could go maybe 3 to 4 times a month. Okay, maybe you might go 5 times a month, 5 to 6. Or we can say 7 and 7 plus. Okay, now we need some boxes. Rectangles. Okay, now we'll go for so we need some boxes. There we go. That's more than sufficient. So if you look at our answer now, this is our complete answer. This is actually the answer to part B. I've done it here on purpose at the top here, even though part B is below this screen here, so we can compare our better answer, our better question, sorry, with the original question. So how many times do you go to cinema? No time frame. Yes, you got time frame. Answers are vague. Our answers are very specific. 0 times, 1 to 2 times, 3 to 4 times, 5 to 7 plus. Okay, folks, I hope this has helped you with this particular questionnaire style question. We shall move on to question 5 next. Okay, Bismillah. Question number 5. On the grid, draw the graph of y is equal to 2x minus 3. Okay, that's the graph we've got to draw. From the values of minus 2 to 2. The green's a bit funky color. Right, now, what we need to do in order for us to do a straight line graph, we need minimum of 2 points, but 3 points are better. That way it ensures if you made a mistake, we can spot it and we can correct the question. So I'm going to consider the boundary points. So you can actually consider any 3 particular points you like. If you want to make life nice and easy, you can choose some positive values between 0 and 2, and then we can extrapolate it, the graph, okay? Or we can just pick the boundary points and the one in the middle. So let's try that now then. So I'm going to go into this grey area over here. Let's just hope you choose a color. Let's just change the color a bit. Let's go for a yellow. Okay, let's have here the original. We can say, oh, that's nice. So x, we have minus 2, and we have 0, and we have 2. Okay, and then we have the y. Now remember, your y is equal to 2x minus 3. So y is equal to 2x minus 3. Now what are we going to do? We are going to be, in this question, substituting this value here into here. So we say, well, that color's not coming up very nice. Let's use a white. So we say now y is equal to 2 times by x. X plus minus y is minus 2. So 2 times by minus 2, and then take the 3. Well, 2 times by minus 2 will give you minus 4. Minus 4 take away 3 will give you altogether minus 7. So minus 7 goes here. Lovely, I like that, that's nice. Okay, the next value here, the 0 value, I'm going to calculate over here on this side, has got more space. So let's choose the same color again for that one. We put the formula again in. So we say y is equal to 2x minus 3. Okay, and now we're going to choose the 0 value for our substitution. Look at this value here, 0. So we say here is equal to 2 times by 0 minus 3. So that equals 2 times by 0 is 0. 0 take away 3 is minus 3. So we got now here minus 3 value corresponding to the 0. Got one more value to do now. We can plot along with that. To be safe, we can do 1/3 value. This is going to be the 2 value. So let's do that over here on this side over here. Let's go back to yellow for the moment. So we have y is equal to 2x minus 3. Back to white. We're going to put the 2 in there now. So we say y equals 2 times by x, so that's time by the x value, but the x value is 2. So 2 times by 2, then take away 3. So first of all, let's look at that. 2 times by 2 is 4, minus 3 is equal to 1. So that 1 will go into the last part of the table, which is here. Now what we need to do now, we need to plot these points as coordinates. So minus 2 corresponds to minus 7, 0 corresponds to minus 3, and 2 corresponds to 1. So let's change color now for our, right, let's choose a blue, I'm sure. So minus 2, 7 first of all. So we're going to go minus 2 along the x-axis and down by minus 7. So that gives us a point roughly there. The next one is 0, 3 over here. 0 minus 3. So we go to 0 along the x, come down by minus 3. And that gives us a point there. The last coordinate is 2, 1. So we go along to the x-axis and up by 1. They're both positive numbers in this case. So we need to draw a line that will go from here to there. So let's pick up our line tool and pick up a green line. And we can start, inshallah. Let's just see if we can do this nicely. Okay, just give me one moment. Okay. And don't feel that you have to stop here. You can actually go through the point and go make the line way longer. That's not a problem. Done. Okay, my line slightly shifted, little bit. Okay, I'm gonna have another go at that one. Okay, just to make sure. So it's gonna get absolutely right. For those of you who are following us on YouTube, I don't want you to think, oh, sir hasn't done it properly. Let's have another go. Okay, well, let's choose a green. Okay, no, whoops, line and green. So again, we're going to go from this point here, just doing slightly like that, through this point here, and through that point here. And we can go past the point, that's not a problem at all. And we're going to, lovely. So there's our line there. So we can now say quite confidently that y is equal to 2x minus 3 is this line here. Okay, folks, thank you very much for joining me on this question and question number 5. Now, one more question to do in order for our take 2 on these questions, because we had issues with the sounds the first time. And inshallah, let's see if this works. Right, bismillah. Right, question number 6 is, this formula is used to predict the adult height of a baby girl. Okay, let's look at the keywords here. So we're looking at a formula to do with height of a baby girl. Height is equal to the father's height plus the mother's height minus 12.5 divided by 2. Okay, so for this, Karen and Keith have a baby girl. I'm interested in finding out how tall their baby girl is likely to grow. Karen, the mother, has a height of 156. Keith, the father, has a height of 172. Use the formula to predict the adult height of their baby girl. Show clearly how you get your answer. Okay, let me just quickly grab my calculator. Just gone over this next page on the next screen. Okay, here we go. Now, what we need to do here first of all is in the FM. Oh, hang on a second. In the F and M, we need to substitute these values of the father and the mother. So let's have a go at this. So we say here now, before we go into the calculator, height is equal to, so first one is the father first. The father is Keith, 172. So we are substituting the values given in the question, plus the mother. The mother is 156, plus 156. And then we have to minus 12.5, minus 12.5, and divide that all by 2. So we need to pop this into the calculator as we see it. So let's go to the calculator, back to math mode. So we have here a fraction calculation. So then we have the 172 and put all of this into here. So we have 172 plus 156 minus 12.5. Okay, and then we divide that all by, when the press replay to bring the cursor down to the bottom, divided by 2. Press equal. So 157.75 is the answer given in the calculator, so let's put that down. Okay. So the height is 157. I haven't asked for any particular degree of accuracy, so we could divide to 2 decimal places or even 1. 157.75. That's the answer for part A. Now, let's quickly show you what part B. So for part B, we're going to need to get rid of this now. Delete this, move the screen up a bit. So please bear with me, folks. I do need to move it up. Okay, let's clear it. That's cleared. Good. And let's get to our mouse. Alright, and let's move the page down a bit. Okay, this is part B. John and Jenny also have a baby. So this is another couple, father. Okay, 1 second, let's quickly grab the pen. So here we have the father and the mother have a baby. John and Jenny are the same height. So the height of the parents are the same. Okay, when they use the formula to predict the adult height of their baby girl, they get an answer 162. Find an estimate of Jenny's height. Give your answer to the nearest centimeter. So, first of all, let's copy down the formula from the top part of the page, which I've got a copy here. I'll write that for you. So we have here the height of the baby. Oops, that looks a bit funky. Okay. Yeah, height is going to be F add M minus 12.5. 12.5. We divide all of that by 2. Now we've been told that the father's height, which is represented by F, and the mother's height are both the same. So if we say, so let F equal to M equal to X. So we'll call the height X. So we can replace these two with X. So we say now H. Now the H is what H we know. The answer, the height of the baby we know is 162, which goes here. So we can now write, okay, we can now write the height as 162. So 162 is equal to, we said F and M are both equal to X. So X at X minus 12.5 divided by 2. So what we've done here, we've got our original formula, we've modified a bit to take into consideration that the father's height and the mother's height are the same by calling them both x. We know what the end height of the baby is, so we already know the answer. We've got to go back and work out what the question was. So what we need to do first of all now, the next part is simplify this expression, rearrange it and make x the subject. So what I'm going to do for that, I'm going to copy this part of the question over here because I have more space over here. Because I'm going to run out of space over here. But here we go. So let's just quickly copy that out and let's just change color. So we say H equals, pardon me, sorry, excuse me on that. Now H equals, we're going to be copying out. Okay, let's go for black. So 162 equals, now the x side x here, this part here, I'm going to simplify that down because x side x gives us 2x. And then minus 12.5. Divided by 2. Okay, let's swap color. Now, if we want to do this question here, we want to work out the value of x. We have to now identify what the actions are. So first of all, x is being acted on by a time by 2. This, we call this the first action. And then it will be minus by 12.5. So this action is the second action. And then it's been divided, this is divided by 2. That is the third action. Whenever we solve or we rearrange an equation, we always move the actions in reverse order. So the last action goes first. So the divide by 2 moves first. So I'm going to grab the divide by 2. Opposite divide by 2 on this side is 2. Time by 2 on that side. So we have 162 time by 2. 160 time by 2, 320, 324. So we have 324 is equal to, copy down the rest of the equation, 2x minus 12.5. Okay. Well, let's just change color once again, just to keep it nice and fresh. Now, remember, our target is to look at the x value. We've moved the divide by 2, that's the third action. Second action was minus 12.5. So now we've got to move that next. So opposite of minus 12.5 is, take it to the side. When we change side, we change sign. So we have a plus 12.5. Okay, so we have 2x over here. So 324 add 12 will give us 336 plus the 0.5. So we have 336.5. Okay, folks, don't give up here. We're nearly finished. Okay, I know you probably think this question is going a bit long, but that's what the question requires. Okay, let's switch back to a green. More colors would have been nice, but never mind. So we have a time by 2. So x, the first action shows the time by 2. Let's move last. So opposite of time by 2. Grab it, take it over. It becomes a divide by 2. Okay. So we have now 336.5 divided by 2. Okay, put that x over here. Put that over here. Okay. So we grab our calculator, we put it on this side over here, and we type in this calculation. So 336.5 divided by 2, and that gives us an answer of 168. Back to let's go for a blue will do. 168.25. 168.25 is our rough answer. The question says I give you answer to the nearest centimeter. So we're going to round up to the nearest whole number, which is here. So if you look at the next number, that's the decider, that's less than 5, so leave it alone. So the final answer for the examiner is 168, and we are done. And that is worth 5 marks. Okay, folks, thank you for joining me on this question. See you in the next one. Okay, the large circle has a radius of 8 centimeters, the small one has a diameter of 4. Write down the radius of each of the small circles. That's quite easy. The radius is half of the diameter. So this 4 becomes 4 divided by 2. 4 divided by 2 is equal to 2 centimeters. Okay, because for the part B, I'm going to work over here at the top. Work out the area of the region shown shaded in the diagram. Give your answer correct to 1 decimal place. So in order for us to do this question here, this part B question here, what we need to do is we need to have an idea. So let's write the idea over here. Okay. What is the idea? The idea is going to be the area of the big circle minus the area of the 2 small circles. So it's going to be the area of the big circle minus the area of the little circle times by 2, because there's 2 of them. So what's the area of the big circle? The area of the big circle is going to be what? Pi r squared. And minus, that's also pi r squared, but that's going to be the smaller r, or the r dash. So what's pi r? Pi here, we leave it as 3.14. Okay. We multiply that by the radius. What's the radius of the large circle? 8. What's the radius of the small circle? Okay, hang on 1 second, folks. Just quickly make that a bit more clean. Right, we'll go back to pencil. Alright, here we go. So we can do 3.14. We multiply that by the radius squared. The radius squared is 2 squared, yeah? Now we need to put this into the calculator. Okay, folks, give me 1 second. I don't know where my calculator's gone. Does anybody see my calculator? Has it disappeared to you? No. Okay, right. Can you click on the calculator icon over there? Use the mouse. You got mouse with you? Yeah. Use the mouse. Click on the calculator icon. It should pop back over here. That's it. That's the green button. And click on that one. There you go. Lovely. Okay. Right, we have the mouse. Mouse is back. Okay. Right, let's grab that. Okay. Okay, right, let's work out now let's do that calculations. We got 3.14 multiplied by 8 squared, take away 3.14, multiply that by 2 squared. Okay, we got that? Yes. So that gives an answer of? Did everybody get that for the homework? 188.4? So that would be the answer that would be here. So that would be an answer of Idris, what do you get for your answer? What is it? 5.9. Yeah, that's right. What do you get? 175.9. Okay, now we haven't done one thing. We haven't multiplied it by 2 because there's 2 circles. So press the mouse, press the calculator. In our calculation, huh? Let's see. I have no idea though. Okay, if you go to replay, can you get back up to the top? Okay, here we go. Alright. Okay. Right, that's just deleted it. Okay, let's just start the calculation again. Okay, right. So we got 3.14 multiplied by 8 squared, take away 3.14 times by 2 squared, and then times by 2, because there's 2 of those circles. And that gives 105.84, which is the correct answer, folks. So, yeah, we need to edit that a bit. So we can now Okay, let's see. So what's our final answer then, Idris? Well done.
It's the 1 GP.
Okay, so 1 decimal place, we have to give it to 0.8. And the answer is centimeters squared. Okay, that's that question. Okay, right. The next question is, okay, Hamza, can you just click on the math icon so it gets rid of it? Just click it so you can back down here. The math, you're over here. That's it, lovely. Okay, let's clear this page. Other? Okay, bring it down. There we go. We got here now, how do you pronounce the name? Nilmini. Nilmini is going to buy some grass seed. Grass seed is sold in 200 gram boxes costing £2.50 each and 1,000 grams. Which box of grass seed gives the better value for money? Right. Okay. So we need to work out how much each gram is costing us, is that right? Okay. So we have 200 grams, let's try the calculation over here. So we have 200 grams of the first one, it costs us how much, how many pence? How many pence? 250 pence. And we got the other one, we have 1,000 grams. And that costs us how much? 1,050
pence.
So what we need to do now, we need to do a calculation that will take us from 200 grams down to 1 gram. Okay. Or in one way you could do, you could even make it even more easier, just do 1,000 grams. If you divide 1,000 grams divided by 5, what's 1,000 divided by 5? 200 grams. So in a sense, if you work this one out to 200 grams, then you can compare it with the top one, can't you? Yeah? That will save us having to do it twice. Okay? Right, let's do that then. Okay, so if you divide this side by 5, we have to divide this side by 5. Okay,
210.
So 1,050 pence divided by 5 will give us 210 pence. Now straight away we can see the large box, it gives you better value for money, yes? Why? Because it costs you less. So this 200 grams will cost you 250, this 200 grams will cost you 210, so this is cheaper. That one. So which box of grass seed? So we have to say the large one. Okay, and there's our working out. Done. So we can say it is cheaper by, okay, well, we just say it's cheaper, isn't it? Okay, which box are better ones for me? Done. You happy with that question? Hamza? Got it? Mrs. Zishan, we happy with that kind of, how we do the calculation? So we didn't need to do the top one. Why? What do you need to do the top one? Because it's just 1,000 divided by 5 is 200, we can just compare directly. Okay, right, let's move on. Is there more question? Any more with that question? No? Good. Alright, let's move it down. Let's clear it first. On the page. Okay, good. That's it. Okay. So now we got here a scatter diagram. I think we just about fit that one in. Okay. Let's see if we can get it in. That's it. Right. Give me my husband, keep on. Control. Is that all that in here? Lovely. We got it all in. Okay, so to complete the scatter graph to show the information in the table, the first 8 points in the table have been plotted for you. So 1, 2, 3, 4, 5, 6, 7, 8. We have to plot 2 points. So 20 for the French and 25 for the German. Okay, 20 for the French. Right, so where are we? 20 for the French. Let's grab a pencil. So 20 and then 25. Yeah, where's that, folks? Can you, if I hit the right one, can you say yes?
Yeah.
There?
Yeah.
Okay. And the last one is 45 French and 50 German. So 45 along the French and 50 for the German will come up here, up to here, right on this over here, yeah?
Yeah.
So there's my 2 points down there. Now it goes complete scatter diagram. We've done that. Okay. Staff was a. And the next part of the question says,
Draw a line of best fit.
draw a line of best fit. Now if you draw a line of best fit, okay, let's draw a line now. Okay, line. Okay. Right, so basically we said that our line of best fit will go through from around about here. I'm going through here like this. Would you say that's a good line of best fit, folks? Right, there's our line of best fit. Okay. So now the question says here, the next question says, draw a line of best fit. Use your line of best fit to estimate the German mark for a student with a French mark of 26. French mark 26. So let's change color. We can be using lines again. Okay, what color should we go for now? Okay, let's go for green. Right. We have to find if we have a French mark of 26. Where's the French mark, Umar? On the bottom, on the side? The bottom. So we got to go for 26. So where's 26? 26 is around about here, yeah? Yeah? So we go up. Okay, Salman. Okay, now we're going to go across. Okay, now, what did you get for yours, Idris? 30. Okay, I'm roughly there. So I've got 31. So anything between 30, 31, 32, or 29, in that region will be sufficient for our answer. So that is going to give us, so question D, part 1. Okay. So we say D, part 1. So I've got on my graph 31 proximate German marks. Right, here come, and the next part is D2. So D2 is asking us, they want to know what will it be if the German mark was 43. So now let's get up our ruler again. Line, which one will we go for now? Blue. And we're going on now on the German side for 43. Where's 43, folks? Tell me I get it. 41, 42, 43 is there. You go across, and we touch the graph. Okay, and we need to go a little bit more. What's that? What's clicking? Okay, don't worry about the mouse flickering. Alright, let's bring the line straight down now from there. I think I'm slightly out there. I need to go slightly across. Give me a moment while I just sort out this little technical. That's better. Drop it down, straight down here. So, what do we get? What did you get for yours, Idris? Lovely, I got 38. I've also got 39. Lovely, fantastic answer. 39 in that region. So we say it is 39 is the French mark. Are we all done, folks? Yes? Okay. Farah, did you manage to do this at home?
Yeah.
Okay. Have you got these numbers?
Yeah.
You have?
Mm-hmm.
Okay. Excellent. Good. Question number 10. Okay, Mr. Remiz, are we focusing on what we're supposed to be doing? Okay, right. Clear that page. Okay, let's get a mouse. Have you answered that question? Yeah? Answer all of it. Okay. The next one says, rotate the shape. Question number 10. Rotate the shaded shape 90 degrees clockwise about the point 0. So what do we do with this one? We need a, what do you say? We need a solid rod that connects our shape by the closest point. So let's do that then. Have you got there? Okay. Now it says 90 degrees clockwise. So where will it be now? The new position? To here, yeah? Lovely. Right. Now, should we try to redraw the shape now? Okay, I'm going to draw it. Should we draw it? Let's draw it with the ruler. Of course, it'll be better. Okay, let's choose the green. Right, now, how many squares do I go along here, Mr. Saf? Because we're going to have this length here coming down there, which is 1, 2, 3, 4, 5. So we can draw it from here. And we're going to go across by 5. So where do I go to? Where do I stop? At 7. Start at 2, yeah? Done. And then we're going to have this part here going to be coming down. How many is that? 4. So 4 down. Okay. Is that right, yeah? Mr. Saf? Yeah? A little bit across? Okay. 5. And then we're going to come down by 3. This one's going to be 3. Sorry for the slightly bit of the wonkiness. Okay. 3. And then the next part's going to be 2. And the next part's going to be 2 again, yes? Okay, folks. Pardon me for the slight bit of slightly bent lines, but just getting used to the new pen. Okay, so that's what your shape should look like. Are we happy with that, folks? Okay, lovely. Now the next question, actually I'll have to delete this one. Has everybody got that new position? Remember, it's moving clockwise. Clockwise is which direction? Is this way. 90 degrees. Okay. Is this way? Are we happy with that? Yeah, you got that? Okay, lovely. Okay, next question. You have to delete this part, folks. Move it down. Okay. Describe fully the single transformation that will map shape P onto shape Q. This is like a nice question here. So shape P to shape Q. So we look at this corner here. It's moved 1, 2, 3 across along the X direction and moved 1 down the Y direction. Call that as a -1. So what do we say? We say it is a translation. You do not use the word transformation in your answer. So we say it is a translation. If I can get a grip of this pen. Translation. Okay, what's that other word that we mentioned now? By. You can say by vector or by translation vector. Okay, let me just write the full. By translation vector. Now the translation vector is normally written in a column format. So we have a column format like this, and we give the X, which is going to be the 3 along the X, and the -1 indicates that we moved it down. So that means it takes P onto Q, and that's done. So that's worth 2 marks, all done. Okay, Zishan, happy with that question? Good? Alright. Okay, now we're going to have to keep an eye on this particular graph here. We're going to have to dictate the rest of the question, otherwise we won't be able to do it. Okay, let's have a look. This one now. Let's make this graph a bit bigger. It's going to work. Oh, that's bigger now. Okay, question number 11. Barbara goes on holiday to Prague. The currency in Prague is the koruna. Well, it used to be. No. This graph can be used to convert between pounds and krona. The exchange is £1 equals to 30 kronas. Barbara bought some things in London. She saw the same things on sale in Prague. The table showed the cost in pounds and in a krona. Barbara thinks the total cost of these things were more in London than in Prague. Is she correct? Okay, let's have a quick look at the table. Let's show everybody who's following us on the net what the table looks like. Here we go. So let's work out the totals here first of all. Okay, let's go back to pencil. Pen. Right. Samir, what do we get for our total for the cost in pounds? So we have
75.
So we have 75 pounds. Okay, now, is this what we get for the total cost of kronas? So I'll give you 7, 11, 12. Okay, I'm just trying to get the numbers right. Okay, whoa. Right. What I'm trying to say is actually 20. Has everyone got 2010?
Yeah.
Yeah, nobody will rub that one out. KC. Okay, sorry about that, folks. It just looks a bit gone. Okay, right. So we got £75, and we got that's the cost, and we have to check that these two, are they equal? Are they more? What are they? Okay, now, so we have to move this now. We have to copy these numbers above and look at how we can do on the graph. Okay, we can even actually, can we do it here as well? I'm sure we can. £75, it actually doesn't cover £75. Now, we know, what is the conversion?
930 crore.
Yes, good. So we know actually that £1 is equal to 30 kc. So what we can do, we can multiply the pounds by 30 and see if we get that, or less, yes? That'd be the easy way of doing it. So 75 times by 30, put that in the calculators please folks. Let's give me an answer please, a nice answer that's correct.
2050.
2,250. So the question says, is she correct? She goes, she paid, the total cost is more in London than Prague. Is that right? Is she right then? Is she right? Yes. Yes. How much was the extra by? So 2,250 minus 2,010 will give us what? 200 and? So yes. So yes, the items cost, what do you say, 240 kronas more in London than in Prague. So we're given an explanation, we got the calculation all there to back us up. And that's lovely. Okay. Right, we've got one or two small questions to do, then we'll have a break. Okay, folks? Right. I think we'll do question number 12 next, and then we'll have a break, inshallah. So let me just quickly clear this page here. Okay, and then we can move it down, and we get the mouse. Okay, here we go. Right. Let's get back to the pencil mode. Green. Right. Are we happy with this next question? Can we all see, ladies in the back? So we have an integer, n is an integer. Write down all the possible values of n. I'm going to draw as myself a small little line just to kind of illustrate it. It's not necessary, but just to illustrate it. So we got -2. We got -1. Okay. We got 0, 1, 2, 3, and 4. Now the question goes that n must be greater than -2. So we have an empty circle over here. But n must be less than or equal to 4. So we can have a solid circle over here. So we need to connect them up. That's the inequality. So it's more than -2 this way, but less than or equal to 4 this way when they join up. So we're looking for all the whole numbers. So the whole numbers are covered by this inequality is this one, this, 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 and this. So what do we write down here? We write down here, make a list, we write down -1, comma, 0, comma, 1, comma, 2, comma, 3, comma, 4. Okay, Zisha, can you remind us why the -2 is not part of the answer?
Because it's bigger than -2.
It has to be bigger than -2, that's why -2 comes in the answer. Lovely. The next question says solve the inequality. Let's quickly swap to a blue color now. Now when you solve inequalities, we treat the inequalities sign just like an equal sign. So unless you multiply and divide by negative, then you reverse it. So we start at the x, okay, over here. X has been timed by 6, I call this the first action. -3 is the second action, so we move the -3 first. So opposite of -3 is plus 3. You don't turn the inequality into equal sign, leave as it is. So 9 at 3 is 12. So you have 6x on this side. Now, okay. Right, next. Okay. Somebody's digging for something. So yes, it opposite time by 6 is? Time by 6 is divide by 6. So we say x is, use the same inequality sign, 2. That is your answer. So that goes over here. Done. That's the end of question number 12. MashaAllah, we managed to do that all within 1 hour, even though we started a few minutes late as well. Alhamdulillah, that's a good place to stop. Let's stop the recording. We'll come back after it's now recording. Okay. Alright. Question number 13. The equation x cubed plus 20x equals 71 has a solution between 2 and 3. Use the trial and improvement method to find the solution. Give your answer correct to 1 decimal place. You must show all your working. Okay, why am I using the mouse? Let's get hold of the bin. Okay, here we go. Right, so we're going to get our pen. I'm going to go for blue. Right, so we're going to first of all have x. We're going to have here x cubed. Okay, ladies, are you concentrating on the back?
Yeah.
Plus 20x. Okay. Right. Right, let's go back to this. Now we're going to try the values they gave us first. Yes?
Yeah.
So they gave us which values first of all? 2 and 3. So if you do 2 cubed into our calculators plus 20 times by 2. What will that give us an answer of? So 2 cubed will give us 8. 20 times by 2 is 40. 40 and 8 is 48. So this one here is too small. Now put the 3 in there, so you got 3 cubed plus 20 times by 3. So that will give you 3 cubed will give you 27. 27 plus 60 will give us 27 plus 60 will give us
87.
87. So 87, now that one is slightly a bit too big. Okay, fine. Now, so can you go check these? Okay. So 2 and 3, now we've got to go in between the 2 and 3 now. Where's our answer? 71. Is it closer to the 2 or closer to the 3? 3. And 3 closer to 3. So which number should we start off with now? So let's just quickly change color. We're gonna, with respect to which we start. Should we start 2.5? But, yeah? 2.5. Okay, I want students to jump in on calculators, please. 2.5 cubed, add 20 times by 2.5. Okay. What do we get for that?
We got 65.625.
65. Idris, do you agree with that?
Yeah.
Okay, then we try, that one's a bit too small, so we go for 2.6.
Yeah.
Okay, Mr. Umar, what do you get for 2.6?
69.576.
2.6 cubed. 20 times by 2.6. Okay, go on then. What do you get?
69.576.
69.576. Samir, what do you get?
5.
Okay, should we try 2.7 now?
Yep.
So we got 2.7. Ladies, are we doing that? Calculations? The ones who are, especially who haven't done it. So, Afira, are we doing the calculations? Sorry, Ifra? So 2.7 cubed plus 20 times by 2.7, what's that give us? A solution of?
That's 73.683.
73. Point
683.
683. Now, we need to find out which one is closer to the 71. Is it this one or that one? There's the way we check that out. We need to take them away. We need to see which one's closest. Is that right, Adisha? So 71 is the number we need to get to. And which numbers do we have? 69 point something and 73 point something. Is that right?
Yeah.
Let's take them away. So I'm going to do over here now. 73.683 is my first calculation. I'm going to minus the 71 target area. And that will give us an answer of 2.683. Is that right? 2.683. Okay. Now, let's quickly do the next one. This one here. So 71, take away this one. So now 71, take away 69.576. What's that give us an answer of, Samia? 71, take away 69.576.
1.424.
1.424. So now we can see quite clearly that this answer here is closer to 71 because it is only 1.424 below, whereas the 73 value is 2.6 above it. So we can say quite confidently that the answer is X is equal to, which one is it? The 69.571, which is corresponds to 2.6. Okay? So X is 2.6 to 1 decimal place. And this is our working out for that. Done. Okay, has everybody got that down? Because I'm going to clear the screen. Once I clear the screen, I can't get it back. So have you get that? All of it. Happy with that? Mr. Umar, you happy with that one? Okay. Okay, let's clear that. Let's change it back to a mouse. So we can move this. Oh. Right. Question number 14. The probability that a seed will grow into a flower is 0.85. The Laurent plants 800 seeds. Work out an estimate for the number of these seeds that will grow into flowers. So what's the calculation that we do? We start with 800 and we multiply it by the 0.85. So in our calculator, what will that give us?
680.
Okay. 680. Samia, what do you get?
680.
Rataba?
680.
So we expect 680 of them to flower. Is that all question 14 is?
Yeah.
That's it?
Yeah.
Wow. 2 marks and that's the question done. Okay. Yeah, 2 marks now. Next question, question number 15. Let's clear that. Okay, the next question reads, the table shows information about the number of hours that 120 children used a computer. So we know that all of these numbers together add up to 120, because I told that at the beginning. Work out an estimate. The word estimate does not mean guesstimate. For the mean number of hours that the children use the computer, give your answer to 2 decimal places. So this is called working out the mean of a grouped frequency table. Grouped frequency table. Okay, done. Now, what we need to know from these 2 values here, this range 0 to 2, we need to work out the what value? The midpoint. The mid value. So half between 0 and 2 is 1. Half between 2 and 4 is 3. Half between 4 and 6 is, and half between 6 and 8 is, and half between 8 and 10 is, and the last one is
11.
So what we just worked out here is all the midpoints between here. Now what do? We have to multiply it by the frequency. Multiply each of those by the frequency. We get an answer. So what's 1 times by 10? Really hard question, folks. Don't stress yourselves. 10. 3 times by 15 is?
45.
And 5 times by 30 is?
150.
And 7 times by 35 is?
245.
245. And 9 times by 25 is?
225.
And 11 times by 5 is?
55.
Right, I need all of these numbers total now.
730.
Okay, Rutaba, can you confirm that for me, please?
Yeah.
Okay, sir?
730.
Okay, lovely. Now to work out the mean, this is the symbol I'm going to use here now. Let's just change quickly color. Red. Which side should we use? We'll write the formula on this side. So this is the mean represented by x bar is equal to the sum of, that's the sum signal, the midpoints times by the frequency. That's the formula. Let's go and check, please. And then we divide that by the sum of the frequency. Don't get put off by that signal notation. That's just the mean sum of. So now let's do it. Now, what the midpoint times by the frequency sum is where? Where is it? There. So that goes on top. So 730 is the sum of the midpoint on the frequency, and we divide it by the sum of the frequency, which is here, 120. So we got 730 divided by 120. That gives us the mean. So what do we get set for that?
6.0833.
6. We've got to give 2 decimal places. 6.08. 6.08. 6.08. Done. So the mean is equal to 6.08. What do you get? Happy with that? Yeah? Okay. Is this how we doing? Good? Okay, here we go. Question number 16 is question to do with bounds. The length of a rectangle is 30 centimeters. Correct to 2 significant figures. We'll show you what that means in a second. Okay. The width of a rectangle is 18 centimeters. Correct to 2 significant figures. So that's the first significant figure. That's the second one. That's tens. That's units. So what that means is it's measured to the nearest. Basically, it's measured to the nearest what? Nearest centimeter. Yeah? Now, nearest whole centimeter here. Now, 18 centimeter, correct 2 significant figures. That's units, and tens. So to two significant figure means to the nearest unit, to the nearest centimeter. Okay? So that is also done to the nearest centimeter. So this here is code for that. Because right on the upper bound of the width. So the width is here. Let's draw a line. So you have 18. The next measurement is 19. And the previous measurement is 17. Now if we look at nearest, so the nearest centimeter means, okay, so this part here will be what? 17.5. And this part here will be 18.5. Why is that? Because this altogether is 1 centimeter. That's nearest centimeter. Half centimeter this way, half centimeter that way. Okay, please forgive me for my. Okay. Okay. It's right on the upper band. So the upper band would be which one?
18.5.
So we write this over here. Oh, we've got a bit more fatness here. Nice big thick pen. Calculate the upper band for the area of the rectangle. Now we know that the area of rectangle is equal to, what's the formula for area? Length time by width. If we want to work out the upper bound area, then we need to consider the length upper and the width upper. Okay, what's the length upper? The length upper is going to be, we have another length upper, have we? So that's going to be 30.5. Multiplied by the width upper which is what you add here, which was 18.5. Has everybody got that calculation?
Yeah.
Mr. Saf, did you get it?
Yeah.
Okay, what was the answer to that then? So we got 30.5 times by 18.5, and the answer to that is 564 point. Okay, have the answer to any degree of accuracy? So what's missing? Units. Put it up there. Done. If you want to find the area upper, you guys consider the length upper and the width upper. Done. Has everybody got that question next? I'm going to wipe it now. Okay, here we go. Question B. Right. Question number 17 says the diagram represents a vertical pole ACD. So we are talking about from here A to C to D, this pole here. Okay, AB is the horizontal ground. Have you done that one, Saf, yet? No? Do together. BC is the wire line. The wire of length 8.5 centimeters. The height is of the pole A to D is 9 meters. So what's 9 meters? All the way up to D. Okay. And B to C is 8.5 meters. I think that this here, folks, is a little bit of a mistake on the printing. It's supposed to be 8.5 meters. Okay? We've got the height is 9 meters, A to D. So, we need to work out this length here. To work out this length here, DC, we need to work out what first? Okay, Hamza, what do we work out first? For work out DC, I need to work out what? I need to work out C to C to A. I need to work at this height here. Right. Yeah? So what we do now, we need to label this triangle. So opposite the angle is always called the opposite. And then opposite the right angle is always called the hypotenuse. And the remaining side is always the adjacent. So our question is between the O and the H. So O and H makes what sound? Oh. So that makes what sound then? So. So. O and H. O and H, you won't make Towa. Towa is an Owa sound. Owa. That's so. So is that we're going to use a sign identity and we're going to write it up here. Done. So what do we know? We know the H. Tick it. We know the angle. Tick the sign. What do we not know? We need to work out the cross it. So what do we need to do? We need to cross it. We need to cover this part up with our thumb. So that gives us this left over. So we're now going to be doing what? We're going to say now the opposite is equal to the sine of the angle multiplied by the, okay, who got this far? Behind him, you got this far? One person. Here this far. Okay. So let's do that then. So we have sine of the angle 68 degrees multiplied by the hypotenuse, which is 8.5 meters. Okay. Right. Let's use a calculator. So we've got here sine 68 okay, that equals that, and then we times that by 8.5. So what does that give us? Okay.
So that's wrong.
Yeah, that's wrong. Hang on 1 second. I think I know what that's wrong. Shift. Menu. Okay, angles and radians. You need, what do we need? Degrees. That's lovely. That's done now. Back to menu. Okay. Right, let's try the calculation again, folks. That's why we have that bit of a dual-liness. So sine, brackets, 68. Let's try that once more. Always check your answer, then multiply that by 8.5. Okay, what, did you ever get 7.88?
Yeah.
Yeah? Lovely. Okay, so let's copy that down now. So we have the opposite is equal to 7.88 blah 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 and so on. Now we need to work out the height of the pole. What was the height of A to D? It was 9 meters. So we're going to have 9 meters minus the 7.88 whatever it is, and let's see what that gives us. So I'm back on the calculator, type in 9. Okay, change back to mass. So 9 minus 7.88
1.12
equals 1.12. Whoa. So that was the answer for the first part. This is my second calculation. And the question says here, it must be at least 1 meter. So DC must be at least 1 meter. Is this at least 1 meter? So is it safe? So we just have to say here, for the pole, have they been? So the answer is going to be yes. The pole is correctly insulated. The pole is correctly installed. Done. Okay, let's move on to question number 8. 18. Okay, Zishan, are you happy with what we're doing so far, yeah? Is it good? Right, I'm going to clear the page now, folks. Somebody, did you get that down? Right. Idris, are you happy? Yeah. Did you get that right? What? Okay, lovely. Right, question number 18. Right, triangle ABC, this one here, and triangle DEF, whoops, DEF are similar. Okay, now, let's give us some measurements here. That's 4, that one's 6, that one's 9, that we don't know, that one's 10.5. Work out the length of DF. So we got to work out which length? This length here. Now, so in order to work out this length, we have to get the 9 and multiply it by what? Multiply by the angle, multiply by the scale factor. So we're going to see how many times has this made. At the moment, we're going to work out the scale factor by looking at the two corresponding values, which is 4 and 6, because they're corresponding sides. So 4 to 6, how does 4 become 6? You multiply by 1.5. So the 1.5 is called our scale factor. So our scale factor is 1.5. Okay? Now, so after you do 9 now, 9, multiply that by 1.5. 9 times by 1.5 will give us 13.5. So that is now 13.5. Quickly change color. Now, the next question, which I'm not going to move the screen for the moment, I'm going to read it out to you. Work out the length of BC. So BC is now which way? So here. So we can say here that BC is the original length, and we multiply that by the scale factor. That gives us an answer of, what does BC correspond to? What does BC correspond to? 10.5. Wow. That 0 looks well. Okay, let's try that one more. Okay. Now, what is the scale factor? We just said the scale factor was what? 1.5. So BC time by 1.5 is 10.5, and then what we do now? That's right. Opposite of time by 1.5 is? So it says BC is equal to 10.5 divided by 1.5, which is equal to? What do you get, Saf? 7. Samia?
Yep, 7.
10.5 over 1.5.
Yep.
So that is the length of BC. Done. Next question. Okay, folks, are we doing good for timing in this bit today?
Yeah.
Nearly? Yeah? When we get to 8ish, we'll have another break. Okay, let's clear this page. Okay, right, let's start a new video file as well. Right, okay, question number 13. We are live now, folks. We have Kylie wants to invest £20,000 for 3 years. She considers 2 investments, investment A and investment B. Investment A is £20,000, earns 3.02% interest per annum, interest paid yearly by check. So this question here, this part here, we need to treat it as a simple interest question. Investment B, £20,000 paid by, the keyword here is compound interest. Okay, now £20,000, we've got to work out the interest. So if you got here, for example, 3.02%, we're going to work that out of 20,000. Okay, so that's going to be 3.02 divided by 100 multiplied by 20,000. That's how much interest you'll earn in 1 year. And if you want to work out how much he earns in 3 years, what do? Times by 3. So I need somebody to work that out for me, please. And that should give us an answer of and the answer is 1812. 1812. That's 1812. Sorry about it's joined up a bit here, folks. Okay, can somebody confirm the calculation for me, please?
1812.
Yeah, got that stuff? You worked it on the calculator?
Yeah.
Yeah, okay, good then. Okay, that's for the first one. So the first one, she earned £1,812 worth of interest. So taking up her total investment to what? 21,812. You happy with that? The next one is compound interest. So now 2.98%, okay, is added onto the original percentage. The original percentage of the full amount is 100. So, is this?
Where did the 21812 come from?
Because I got 20,000 here, original investment here,
Yeah.
and then I added onto it how much you made extra.
Okay.
So £20,000, add 1,812, gives you 21,812. Okay? So now you have 2.98% compound interest. If you want to work out the actual percentage, the multiplier, so 2.98 add 100 will give us 102.98. Is that right? Is it? Yeah? So now if you want to turn the percentage into a decimal multiplier, we divide by 100. So we move back by 2 places. So it becomes 1.0298. So we got £20,000 and we multiply that by the multiplied 1.0298 and for 3 years like that. So Saf, can you do that calculator for me please? 20,000 times by 1.0298 power of 3.
2.841.
21841. 0.8166.
1167. 1167.
Okay, that'll do. Okay, now what do we know? What do we know? Which investment is the one that gives you more return? Investment? Because this one is 21812, so 21841, so this is more. So investment B is the one which is the answer. Okay, if I was here, I wouldn't do investment A or B, I would do investment C, put it into charity, and you get the best results, the best return. Okay, right, that's the end of that question. Let's move on. Let's clear the page first of all. Oh, nice question. Okay, put your hand up if you're doing question number 20. Nobody has done question number 20. Okay. Which you have? Okay, good. Question number 20. P is the point with coordinates 2, 1. What's the coordinate of P, Mr. Idris? What is it? And what's the coordinate of Q?
14K.
14K. It says that here the gradient of PQ is 1.5 or 3/2. Work the value of K. This is called, I will call this question a reverse gradient question. Because they're giving the gradient, you gotta go and work out the coordinates. Now, who can remind me what is the formula for the gradient between 2 points? If I want to work out the gradient, we call the gradient M. The gradient is equal to what? We say is y2 minus y1 divided by x2 minus x1. Okay, now let's label up. This is going to be my, okay, this is going to be my x2. This is going to be my y2. This first coordinate here, I'm going to call this one my x1. And this one will be my x, sorry, pardon me, Robert. Okay, that's right. That's going to be called my y1. Okay, so let's look back at the formula. The formula is telling us to put into here y2. Y2 is, what is y2? What is y2, folks? K. Minus y1. What's y1?
2.
Y1 is 1. Divided by x2. What's x2?
It's 14.
14. Take away x1. x1 is 2. And all of this should give us an answer of, what is the answer for the gradient? What's the answer for the gradient? 3/2. Not 3.5, just 3/2. Okay, now, we need to work out, what do we need to work out in this particular instance?
It says work out the value of K.
So we need to work out this. So what should we do with the bottom part here?
Take to the top.
That's right, take all of this, dividing by 14 minus 2, we have to times it by 3 now. So 14 minus 2 is? 12 times by 3 is?
36.
So let's go over here now. So 36 is equal to K minus 1, and then opposite of divide by 2 is? Times by 2. Okay, now, still want to work out the K. K is being minus by 1 and times by 2. So what do we do now? Idris? Minus 1 times by 2, what do we do now? Opposite times by 2 is?
2.
So 36 divided by 2 is?
30.
The brackets go now. And then opposite of minus 1 is?
Plus 1. K is 19.
Whoa. And we have worked out the value of K. Okay, next question. Can I delete that, folks? Yeah?
Yeah.
Yeah, folks, we're back on live. Make B the subject of the formula. Now, what can you tell me, Mr. Idris, about the B? Have you done this question, Idris? Huh? Well, look, we need to all pay attention then. Who's on this question, number 21? 1 person, 2, 3, 4, good. How many B's do we have first of all, Idris? 1 here and 1 there. So we need to get rid of the fraction at the bottom. Opposite dividing by all of this is time on the other side. So we have b minus 5, all of this, so bracket there to indicate all of it, multiplied by a is equal to, copy the top bar again, so it's 2 minus 7b. Now we need to get the b out of the bracket, we need to multiply out the bracket to release it. So if b times by a is ab. Minus 5 times by a is minus 5a. Okay, 2 minus 7b. Copy down. Okay. Ifra, you got that? Now we need to get the b's onto one side. Is that right, folks?
Yeah.
Because they've got b here and a b there. Let's get the b's together. Let's grab this one here and take it from the right hand side to the left hand side. We take the minus 5 from the left hand side to the right hand side. So now we have AB minus 7B, opposite minus 7B is plus 7B equals 2 already there. Opposite minus 5A is plus 5A. Now we have, let's change color once more. We have a B here and a B there. What should we do those B's, Idris? We should factorize them, not cancel them, factorize them. So this is, I say A times by B plus 7 times by B. So the B can come out. So what we left with? A add 7. Okay, now what's next? No, we still work out the b yet. So b has been timed by all of this. So opposite times in by all of this is, that has to go to the other side and become divided at the bottom there. So we just try to fit it now. So we say b is equal to 2 plus 5a, all of it divided by a plus 7. And that is the answer. I'm going to write it over here to make it a bit more clearer, folks. I think it's a bit messy there. 2 add 5a. Did you get that now? Divided by a plus 7. Answer. Okay, yes? Question 21. How many questions you got left?
5.
Wow. How many questions left? Let's do one more question for us to wonder, yeah? One more question. Delete that. Let's take the pen, just take the pen down. Okay. Now, question number 22 says solve this quadratic equation. Give your answer. Let's make it a pencil. Answer correct to 3 significant figures. What does that indicate to us straight away? What type of, how do we do this question? Factorize in which way? We got 3x squared plus 2x minus 4, 3 significant figures. Can you factorize to 3 significant figures? No, most likely not. So here we don't use the factorizing technique as that we use. We have to use what do we use? The formula.
What formula? X minus b plus minus b squared root 1.
Yeah. This formula. So the 3 significant figures straight away indicate to us that you must use the formula. Now let's have a look what the A and the B and the C values are. So let's go back to our original here. So we have here A B, and C. So what is A? A is 3. A is 3. A is the coefficient of x squared. What is B? 2 plus 2. What is C? Minus 4. Okay, let's write them down here more clearly. So A is equal to 3. B is equal to 2. I don't need to write down plus 2. That will do. And for C, I do need to write down minus 4. Oops, a bit of a funky what maybe. Oh, right, just a little bit of rubber. Okay, let's try that again. Ladies, are we concentrating? Oh. Alhamdulillah, that's much better. Right, what we're going to do now, we're going to start plopping there. We're going to start substituting these values into here. Okay, so the A value will go into here, and the B value will go here, and A will. Okay, let's do that now. So X is equal to minus B. So what's the value of B? 2. So write down minus 2. Plus or minus, we can only put one calculation into the calculator anyway, but put more. B squared. B squared is 2 squared minus 4 times by A times by C, which is 4 times by A, which is, what's A? 3 times by the C value, which is minus 4. I'll put a little bracket around that just to, so it doesn't get confused. And all that's going to be divided by 2 times by A, which is 3. Now we need to put all of this into the calculator. We definitely need to use the calculator now for this particular question. Right, young man, have you got my calculator there? Is it?
So I can put plus or minus either.
No, you got to put 1 first, put plus in first. Okay, we're going to use a calculator for this, folks. Show you how you do it on the calculator. Right, okay, now, part of my calculation is covered by the calculator. I got no space, we need to move it. So let's just go to mouse. Okay, let's try to move it a bit. Okay, here we go. Right, so we're going to put minus 2. We need a fraction button, yes? Yeah. Fraction. Minus 2. I use this minus here. Little baby one. Minus 2 plus. We don't put both of them in, we put 1 in. Plus for the moment. Square root. Where's that square root, folks? Shift. Square root. 2 squared. 2 squared. Take away 4 times by 3 times by little brackets now. Put the little baby minus in there. And the 4. Close the brackets. Are you happy with the top line now, yes? Yeah. So this top line here matches this top line here. And then we use replay to bring the cursor down. And then on the bottom, what do you type on the bottom? 2 times by 3. Oops. Right, okay, pardon me, folks, I just got to bring the calculator back, inshallah. Give me a second, folks. Okay, good. That was close. Alright, what do we type on the bottom line? On the bottom over here, we type in 2 times by 3. So 2 times by 3 equals 0.86851.
I'll get 0.943923.
Okay, what do you get, Samir? What do you get in your calculation?
24. What else am I different to that?
Okay, right. Let's say what everybody else gets. Yeah. Stats are the same. The tables are the same. What about you, Adil? Please.
Oh, yeah, I've got it right.
Yeah?
I've got it.
Okay. Okay, folks. Right. 0.86851. So if you do that 3 significant figures, it'd be 0.869. 9. So we can say over here. Let's change back to pencil. So we say x is equal to 0.869. Was it 0.869? 0.869 to 3 significant figures is one answer, folks. We haven't finished yet. We're going to go back and change the plus in the calculator into a minus. Okay, so let's get rid of the pen. Go back to the mouse. So we need to use replay. Okay, we could try to get the mouse back over here. Okay. Right. Okay, now let's try to get the replay in the right place. Okay, oh yes. Moving right. Okay, now that plus we can delete it. Press del and change it into a minus. And then press equal again. And what do we get now? Has everybody got the answer? Zishan? Okay, so the second answer for x is equal to minus 1.54. That's correct, because first, second, third significant figure, you look at the, that's 5 or more, add 1 minus 1.54, 2, 3 significant figures. Okay, remember, that's my first significant figure, second and third. So even though it's got 3 DPs, it's still 3 SF. And that's done. Okay, we're happy with question number 22 now?
Yeah.
Is it all done? Hang on 1 second, folks, before you disappear. So what do we get? Okay, that's beautiful. That's lovely. Okay, folks, are we ready for another break? Okay, let's stop the recording. Okay, Bismillah, we're live. Question number 23. The table below shows the population of each of 3 villages. Ashley has 243, Brigby has 370, and Ayton has 127. Now, if we add them up, whoa. If you add them up, that will give us a total of, folks, what will it give us? 740. That's the total population. Okay. Now, it said there are 50 people from Brigby in his sample. So this, what we're saying here is this 370 divided by the total population. Smir, you got this calculation, Smir, right?
Yeah.
You got it right, Smir? Okay, what's your answer then, Smir?
Answer's 25.
That's not right. So pay attention.
Yeah.
370. No. Okay, 370 divided by 240. Hang on a second, you're ahead of me. Time that by the actual stratified sample, because we don't know what it is at the moment. The stratified sample is equal to 50. So 50 is the answer to the question. So we have here, you said this is equal to a half.
Yeah.
0.5.
Yeah.
So a half of my stratified sample is equal to 50. So what is my stratified sample then? It is
50 by half.
100. So half of 100 is 50. So my stratified sample size is 100. Stratified sample. Okay, is 100. Okay, Smir? Right. So now we've actually worked out from this question what the stratified sample actually was. We can now work out how many people from Ayton is in the sample. So Ayton is 127. So 127. We divide that by 740. And we multiply the answer by the stratified sample, which is we just worked out here just earlier, is 100. Okay, so can you put that in the calculator, please, folks, and what you get?
I got 17.162.
17.162. We've got to give it to a, well, okay, so we can't have 70.162 people. So we're going to choose how many? We're going to round to the nearest whole number. So how many people are we going to have? Oh. So the final answer is 17 people is the answer to that question. Next question, question number 24. Okay, let's clear this page. Okay, come on, Smith. Okay, if you happy with that? So here they actually gave us the answer. You got to go back and work at stratified sample size and then use it for the next part for the calculation. I think we should just about get question number 24 done before you guys. There we go. I'll do those next inshallah.
Ready?
Ready?
Yeah.
Okay, lovely. Let's clear the page. Let's move them. Let's move it down. Okay, question number 24. Question number 24. Okay, what's an important word in this particular question? An important word in this question is diagram not accurate. That means do not start measuring things. That's what that means. Now, they've given us a triangle A, B, C, a non-right angle triangle, and they've given us some angles in here and some lengths, and they want us to work out the area of this triangle. To work out the area of this triangle, what do we need? We need to know, for example, a length and another length, and we need to know the angle in between it. Okay? So we know the angle in between it. We know this length. What's missing? What's missing is that length. So we need to work out that length first. Because the formula for the area of a triangle, of this type of triangle, is area is equal to, come on folks, tell me, half AB. That's right. Okay, half ABC. That will give you the area. So to work that out, what that means here is this is the angle that would be in the middle here. I know it's labeled B, but this angle is referred to the angle which is surrounded by two sides, A and B. Okay? Now we need to work out this first of all. So we got 47 and 58. Let's work out this missing angle over here first of all. That should help us. So 40 add 50 is 90. 90 add another 15 is 105. So we have 105 altogether, these two. 180 minus 105 is, so this missing angle here is 75 degrees. Now, okay, what do we know? We know this angle now, and we know its corresponding side. Join them up with a dumbbell. This is where I showed you before. We know this angle here, and we don't know its corresponding side, so that makes another set of data. So what do we use now? We use the sine rule. Okay? So we say A over sine of A
equals B over sine B.
Equals B over sine of B. Okay, now, even though our angles and our so our little a here, okay, is this missing angle, missing side here. Okay, even though it corresponds here. Okay, well we could, if we wanted to make our, that's the general sine rule. A over sine A equals B over sine B equals C over sine C. Okay, but according to the labeling here, this C, we could actually change the, we can make it now specific. Let's make it specific to this particular question. So it'll be, what's this side called? C. Here. So we could say now C over sine of C, making it specific to our labeled diagram, is equal to, and we got, what we got here, this is called? This is, what's this? Little a. Okay, so that could be A over sine of A. So that here was general formula. This is now specific, that's to our particular question. So we don't need this one anymore. I'm going to rub it out. Now let's put the values in there. Now what is the value of C? C is what we're trying to work out. We don't know what it is at the moment. So C over the sine of C. What's the sine of C? The sine of
58.
is equal to A. What's A?
220.
220. We divide that by
Sine of 75.
sine of 75. Sine of A. Okay, now if I want to work out the value of C, C has been divided by sine 58. Opposite dividing by sine 58 is?
1 by sine 58.
So now we can say here, now quite confidently, C is equal to, I think we might need to rub off the bottom formula, folks. I'm sorry about that, but it has to go. Bring the space. What color are we on?
Red.
So C is now equal to 220 multiplied by the sin or the sine
58.
all divided by
Sine 75.
okay, I'm pressing the button there. Oops.
Sir.
Sorry about that, folks. I just really get used to this pen. Sine of?
75.
Sorry about that. It's difficult with the pressing buttons and stuff on the pen. Okay, right. I need to go into calculator now. I'll get my calculator back up. I need to put my calculator on. Where's my calculator, man? Okay, here we go. So I'm now going to put all of this into calculator in one go. So we're going to use the mouse button here. So there we go. Mouse button. So we have a 220 times by the sine of 58. Replay, bring the cursor down the bottom. Sine 75. Okay, what do you get, Samir?
I got 193.15207.
Is this same thing? Lovely. So we can go back to the red pen. So how many significant figures? At the moment, this is just the side that we're using. So I'm actually going to write down quite a few different places. 193.152 to make sure we don't lose any accuracy. 07. Right. That's just the C value. Oh, sorry about that. Okay, now let's move this out of the way for a moment. Nearly finished, folks. Don't worry, I can hear the deep sighs. Right. What we have just worked out, folks, looking back at our diagram, is this side over here now. Let's get back to a pen. So C is equal to, this side is equal to 100, and I'm just writing the whole numbers, 193. So we know this angle here, and we know the two sides, either side. We can now pop these values into the formula and work out the area. So let's just do on top of here. So the area is equal to half time by the adjacent sides, which is A and B refers to, which is going to be 193.15. Multiply that by 220. Multiply that by the sine of the angle in between it. What's the sine of what? 47. Put that all in one go into the calculator, and that will give us the answer, the final answer for the area of this question.
So is that 47 or 57?
47. 47. Okay, come on, somebody give me please the...
15538.
Beautiful.
70642.
So you got here 1
5538.
5538.
38. 70642.
Okay, 0.706. Now, remember, now we can give this answer correct to 3 significant figures. So we say the final answer is going to be A is equal to, so 1, 2, 3, stop here. So that's less than 5, so the answer is going to be 1, 5, 5, and then 0, 0. What? Meter squared. Okay, we're going to stop there now, folks. Okay, now. Fine. Let's stop the recording. Okay, welcome back to the next question. This is now question number 25. Sally has a bag of 9 sweets. Okay. In the bag there are 3 orange flavor sweets, 4 strawberry ones, and 2 lemon ones. So you straight away want to work out the probability of an orange. That's quite straightforward. It's with 3 out of 9. Don't worry about cancelling at this stage here. Probability of strawberry is equal to 4 out of 9. Probability of lemon is 2 out of 9. Probability of lemon is 2 out of 9. Okay. Sally takes a random 2 of the sweets and she eats them. This is a key word in this question. The word eats indicates here that there is no replacement. So she doesn't put the sweets back in. Obviously, if you eat something, it's not going back in the bag, it's going into your belly. Okay, so that is important. There's no replacement. Very important. Work out with the 2 sweets Sally eats are not of the same flavor. Okay. The best way to work that out is do the opposite. So the probability of not getting the same color is equal to 1, which is the maximum probability, minus the probability that they will be the same. So this is one way of doing this type of question. Now, what is the probability they will be the same? So we can look at this model here. So I'm just going to copy my 1 over here. Now, the probability they will be the same means the probability it will be an orange and probability that we'll have another orange. Or we'll have a probability that it will be a strawberry and another strawberry. Probably another strawberry. Or it will be probability of a lemon followed by another lemon. Now, this is very important. Write down the idea. And from this idea, we can see what the symbols ands and ors means, can translate this probability language into mathematics. Okay, let's go for that. Let's go for a red. Now, and in probability means times. And means times. And means times. Or in probability means add. You can have green for that. So O means add. O means add. Let's put the value back here. So probability of orange, the first orange is 3 over 9. Now remember, after taking out the first orange, you now have only 2 oranges left, and you have now a reduced number of 8 sweets in the bag. So the probability of the second orange changes. That's what it means by no replacement. Similarly, for probability of strawberry, the first strawberry is 4 out of 9. So put down here 4 out of 9. Once you've taken the first strawberry out and eaten it, there's only 3 strawberries left, and there's only now 8 sweets in the bag. Probability of lemon, the first lemon is 2 out of 9. You've eaten that lemon, you put your hand back in the bag, you only now have 8 sweets, and you have 1 lemon left over. So that has to go here, that goes here, oops, and 1 minus that. will give us our answer. Okay, as it's a calculator paper, you can just throw it into the calculator. So let's get our calculator and literally throw it in. Here's the calculator. Now I'm going to type this in exactly as you see it here, straight into the calculator. So we need 1 minus bracket fraction. So let's go for it. 1, take away, brackets, that's first fraction, this first fraction here. So we have 3, replay, 9. Replay, bring the cursor back up here, we've got times. So it's times by 2 over 8. Another fraction. So we've got 2, replay, 8. Press replay to bring the cursor back up. And then we've got plus. We've got second fraction here, another fraction, 4 lines. So fraction button again. 4, replay to bring the cursor down 9. And then we've got times by 3/8. So times that, oops, hang on 1 second. Oops, I've got to bring the replay back up properly. That's it. Make sure the cursor's up here. Then times that by 3/8. Another fraction. 3, replay, 8. Bring the replay back up, the cursor. Now we've got another add, 2 9s. So add the fraction, 2, replay, 9. Bring the cursor back up, press replay, and then time by 1/8. We need it finished. Time by, here's the middle now, we need it finished. 1/8. Replay, and close the bracket off. Now if you look at this carefully here, this should be identical to this, also called natural display. So let's double check on 3 2 4 3 2 1 3 2 4 3 2 1 9 8 9 8 9 8. So it looks lovely. Press equal, and that gives us an answer of 13 over 18. Right, let's go for that then. Let's put answers on. So we have 13 over 18. I'm sure that was what the answer was. I'm going to double check that by clicking back on the calculator, see what that was. Yes, 13 over 18. That'll do. Okay, folks, thank you for joining question 25. See you in the next question, inshallah, 26. Okay. Bismillah. Alright, question number 26. We've come to the end of the paper, and I'm glad we have. Getting exhausted. Alright, the diagram shows a regular hexagon OA, B, C, D, E. OA, O to A is the same as equal to D to C, which is 6A. O to C, let's put the colors. O to C, which is O to C, is equal to 12B. Find B to C in terms of A and B. Now, because it is a regular, the keyword here is regular hexagon, we know if that is 6A, we know it's parallel to this one, that's also 6A. Okay, so at the moment, we can say that all of this, the entire vector here is also 6A. That is 6A, that is 6A. This is 6B, is parallel to this and the same length, and so this is also 6B. So let's try it again on this. So this one is 6B. Done. B to C. Well, B is here, and we want to go to here. Now, because we don't know how to go on the direct route here, we haven't got a vector to describe this part here. We have to go what I'll call the scenic route, which is this way, followed by this way, followed by this way. So we can say that B to C. Just think of it as though you're going down a road. I want to go from B to C, but I can't go this way because this road hasn't been built yet. So I know the long way, which is from B to A to O, and O to C. We can write that down. So B to C equals B to A. So B to A plus, and then we're going to add that A to O. Okay, and then O to C. Now let's go. Now the vector 6b is going in this direction, going up, but we are going down. We go from B to A in this part. So if we go in the opposite direction of the vector, we have to reverse the vector. So 6b becomes minus 6b. Okay, hang on 1 second. My 6 looks a bit weird. Okay, let's just rub the 6 out and just try it again. Don't want students to think I've written BB. Okay, and then we got A2. Okay, now what? Excuse me a second. I'll just get rid of that for the moment. Okay, now we have to go now from A to O. That's why we decided A to O. Now 6A is going that way. We're going in the opposite direction. We must reverse this vector. So that is also minus. So it becomes minus 6A, not 6A. Okay. We normally put a little dash above the vector sign to indicate this vector. And then we're going to go in the direction of O to C, because O to C is next. So that one is the first plus. So we're going in the direction of the plus 12b. That's okay. Now we need to simplify all of this. So adding like terms. So if we look at this like terms, what do we have? Let's see. Oh, the green highlight is not very nice. So we have here minus 6b here. And we have a plus 12b here. So these are like terms. So we can add them up. So minus 6b and plus 12b. So like saying 12 bananas. I have 12 and minus 6 bananas. So I am left with 6 bananas. So you could write 6b first. And then minus 6a. That gets left as it is. 6a. Now, okay, that's perfectly fine. I mean, normally in algebraic, we could have the A quantity before the B, but this is perfectly fine mathematically. So we finish it off by saying B to C is equal to 6B minus 6A. You could also factorize it as well. There's lots of things we could do at this point here. You could put a 6 outside and put the B, take the B, 6 as a common factor, minus. This line on top indicates this is a vector. So there's 2 different ways of writing down B to C. At least. This one and that one. Both of them perfectly acceptable. Okay. Question part B. Okay, question part B is off the bottom of this page over here. And if I move it down, I'll lose all of this information for the moment, which I might have to lose anyway, to show you. So what I'm going to do for the moment, and if you can, those of you following us on YouTube and my YouTube students, please copy all this down, pause it and copy. I'm going to move down now. I need to get rid of this for the moment because I need space. So I'm going to clear it. Right, let's move down to show you the next part of the question, and we can see how we deal with that. So this is the next part of the question. X is the midpoint of CD. So we go back up to the diagram. X is the midpoint of CD. X is a halfway of this CD. So we said before this was 6. Hang on, let's get back to a pen. Okay, we said before this was 6A and that was 6A. Now we're telling that in the middle. So that was 6A from there to there. So we can now quite confidently say, so this part, this half here is going to be, whoa, that's a bit. Okay, let's try the 3 again. Okay, folks, please forgive me for, I'm just getting used to this new technology, this new equipment. So my handwriting is taking, I'm relearning how to write. Okay, and also this part here, this is also 3A. Because we said originally, this 6A here is also 6A here, we said in the question. And because now we've been told that X is the midpoint, let's say 6A divided by 2 is 3A, that half is 3A, that half is 3A. Okay, I'm actually going to I'm going to read to you the next part of the question. Right, let's just refocus this question. And it also says, why is the point on BC, why is the point on BC such that, why is the point on BC extended such that BC to CY is 3, 2? Why is the point on BC? So we need to, okay, what I'm going to do here first of all is draw a line. Okay, let's get a line function here. And, okay, we'll draw a line. And we'll draw the line in black. So we are now going to go from here. And we'll go to BC. And we'll draw the line like this. Okay. It's saying here, the Y is the point on this line here, such that this BC to CY is a ratio of 3 to 2. So for the moment, I'm just going to, let's just go to a blue or something. So I'm going to smooth here. I'm going to smooth around here, roughly. Just a guess. So put white down there now. This is the point Y. Okay, what I'm doing, I hope this one's out here because it's actually getting into my way a bit. I'll just replace them somewhere else. So let's go to this at the moment. Okay, and let's put them back in. So we put that over here. Three. Okay, let's put some of the black line back in. Whoops. Alright, I'll take the black line off. Okay, now. Sorry folks, I have to read out this next part of the question too because I can't keep moving this page up and down because we'll mess with the diagram. So we've been told, I'll write it down actually, I think that'll be better. I'll write it down. The next part of the question. So we've been told that X is the midpoint of CD. I'm just copying it all down so you can see clearly what's been written that you can't see. So Y is the point on BC extended such that BC CY is a ratio of 3 to 2. So that's the information given which is below here in the question, which you can't move up and down. I've copied it up for part B. Now here comes the question now. The question is actually saying, prove. Whoa, a bit of my thinking. Prove that O, X, Y lie on the same straight line. That's the question. Okay. Now, first of all, in order for us to prove this, we have to do it in two parts. We have to look at the O to X and O to Y. Okay, we must start from the same point. So let's change the color again. Let's go for. We haven't done yet. What do we do? Okay. So first of all, we're going to work out O to X. O to X, and then we're going to work out O to Y. Because they start at the same point, to start at the same point, if they are parallel, that means they're on a straight line. Let's work out O to X first of all. So we're going to work out O. So So let's draw a straight line. Okay, let's let's the line function. Let's go from O. Okay, and the y point I put here, that was just my guess where it's going to be. According to the diagram, to make the diagram look a bit more better, I'm going to rub that y point out from there, which was I could put it anywhere on that line, as because it's a sketch, it's just an idea. And put it on here so it agrees with the idea. So please bear with me on that one. Okay, so I'm just going to replace y in my diagram here. So when I look at it, it looks nice and good. And I'm going to get a rubber and I'm going to rub off this the y position. Okay, that's lovely. Okay, and let's get back to this. Okay, there's the x point, and there's the y point, and there's the O point. So if I want to go from O to x, let's look at O to x. I want to go from O to x. Well, I can't go directly because I don't know what this vector is. But what we do know is how to get from O to C and C to x. So let's do that then. So let's highlight our route. Okay, let's highlight our route. So we're going to go along this route. Oops. Oh, we're going to go along here and then along here. Oh. Okay, let's write that down. So O to x is equal to O to C, then C to x. So we say O to C plus C to x. Now O to C, they've told us here in the line it is equal to 12b. So we replace that by 12b. And then C to x now. Remember, 3 is running up, we're going down. So we have to reverse the vector because the vectors are directional. Minus 3a. That's O to x. Okay. Now we're going to look at, so we said before, to prove the OXY line schema, we're going to look at O to x, then O to y. Because they start from the same place, if they're parallel, that means they're on the straight line. So let's look at the next part of the journey, is O to y. Okay, now O to y, okay, we need to go, right, now we need to consider the ratio they gave us earlier here. This ratio here. It says the ratio of B to C to Y is 3 to 2. So this part's worth 3. Okay, and that part is worth 2. Now, did we work out B to C earlier? Yes, we did. Lovely. What was B to C? I can't see it. Okay. Question B to C. Okay. Was, okay, now that we can't see it, alright. So B to C, let's put it back in. We said it was 6b minus 6a for my calculation. Let me just double check that. I need to just look back at my written notes myself, because I'm getting something that's looking a bit strange. So B to C is going to be 6. Yeah. Okay. So B to C is 6b minus 6a. So we write down here 6b minus 6a is this part. Now, if this part has a ratio of 3 to 2, okay, so this is with 3 parts plus 1 part. one part is going to be, if you divide it by 3, that will give you 2b minus 2a. This is two parts, so this part here will be 4b minus 4a. Okay, I'm going to get rid of this y for the moment. Please excuse me, folks, because it's just in the way. Oh, I'll put it back in a second. 4b minus 4a. Okay, here's our y over here. Okay, I'm going to go through that ratio part again. It said this part here is worth a ratio of 3, and this part is worth a ratio of 2. So if this is worth 3, then one of them, what's one part worth? So divided by 3. 6b divided by 3 is 2b. And we want now two parts. So 2b, double it, gives you 4b. If you have to do is minus 6a divided by 3, that'll give you minus 2a. That's worth one part. We now have two parts. So minus 2a double give you minus 4a. So that part's worth. Now we're in the position doing O to Y. So O to Y, let's get rid of this yellow bit here first. Oh, I don't know whether we can do that now. Do a different color. Let's pick now a pink. Now we're going to go from O to Y. We don't have the direct route, so we're going to go now this way. O to C, and then we're going to go from C to Y. So let's change back to a blue. So O to Y is equal to O to C, and then we're going to do plus C to Y. Now O to C has been given as 12b there, and O to, okay, we said O to C, pardon me, that should be really C to Y. Forgive me please folks, a little bit of a, okay, there we go, right. So let's do that one again. That should be C to Y, sorry. C to Y. So C to Y is 4b minus 4a. Plus 4b minus 4a. Now we need to simplify this, like terms to like terms. We have 12b, add 4b, that will give you 16b, and that will give you minus 4a. Okay, right. So we now need to show that, okay, that this vector here, and this vector here, primarily this part here, that these two are parallel. So what we can do first, let's start factorizing them and see what they look like. So 12b minus 3, if you take the factor of 3 out, so we say O to x. So take the 3 factor out, we're left with 3 times by 4b minus a, and that's what we use this vector. That's what O to x is equal to. Let me do O to y. Factorize that. We take the factor of 4 out. So put 4 on the outside. We left with 4b inside minus a. So, lovely. Now we're running out of space a bit. Let's hope we can fit it all in. And let's change your green. As we can see here, O to x is 3 lots of this, and O to y is equal to 4 lots of this. Now, so these are definitely, what should we say? These are definitely parallel vectors. Okay, why are they parallel? Because they are a multiple of the same vector. So that's 3 lots of 4b minus a, O to y is 4 lots of 4b minus a. So they are essentially the same vector, but this one is longer than this one. So we can say here, since OY and OX are both multiples of 4b minus a. Since they are that, since they are multiple of that, they are parallel vectors. Now, because these two are both multiples of the same vector, that shows that these two vectors are parallel. OX and OY are parallel. Okay, for the next part of the explanation, I have to do on the side, change to a white color. I've literally run out of space on the screen here. This is the second part of the explanation, which I'm going to do over here. Okay, now, so we can say since OX, whoops, right, that doesn't look too good. Since OX and OY have a common point, and they are parallel, therefore we can say OXY lie on a straight line. Okay, as we don't need this line for now. Lie on a straight line. Okay, that's the end of that question for the end of this paper. What a journey for that paper. Using this new technology. Okay, folks, I hope this helps my students who came yesterday for the last session for the examinations, and all the YouTube students who have been commenting and leaving some nice positive feedback and asking questions on YouTube. Okay, folks, I hope you get the grade that you're looking for. Please give me some feedback when you've done your examinations and how well you've done. It'd be nice to hear how my students on YouTube have also found the examination. And please also drop me a comment when you've got your results to let us know how well you've done. Thank you very much for joining us on this journey to this paper, and hopefully see you on the next paper if you can fit it in before the exam. And go and get that A star, folks. Go on, it.